we did not get to the identities in 6.4. When I got back to my office and looked at them, I thought, you could have handled that without seeing an example probably. But I'll do 2 or 3 of them just for a little bit of practice. Number 20 is pretty good. Remember, proofs are the only time I'm going to be picky about the way you do it, because you're not just simplifying something or finding an answer. You're doing a proof. So start with one side, you copy it, work on it till it becomes the other side. You'll have all of these formulas at the top of the page. So look at what you're starting with and compare it to all of those formulas. Which one do you think we'll need based on what we're starting with? Yeah, this sine of 2 alpha, we have a formula for sine of 2 alpha. Now, we do have to recognize that sine squared means sine 2 alpha times sine 2 alpha. Don't be confused about what sine squared means. But then I can use the formula for sine 2 alpha is 2 sine alpha. And actually, instead of writing this down twice, I meant to just write it down with a square outside, but that's the same thing. Sine of 2 alpha is 2 sine alpha cosine alpha. And I can either write that again or just put the square outside. And that's all I've done in the first step. Then what? I might go ahead and say 2 sine alpha cosine alpha squared would be 4 sine square alpha cosine square alpha, because I can see something good that would happen if I did that. Yeah, a pair of sine square alphas cancel. Was that supposed to be, let me see if I have a typo right there. No. If you look at what you want to end up with has sine in it, and what you have has cosine in it, then you can rewrite cosine square in terms of sine square. You can write cosine square as 1 minus sine square. And when you distribute the 4, you'll have exactly what you wanted. So I don't think that was much harder than anything you've done in a previous section on proofs. What about number 26? Normally I start with the more complicated looking side because it's easier to simplify than to expand. Here's an exception to that. The double angle formulas actually expand an expression. So I think I could take that sine of 4t and expand it, and then maybe have to expand it again and hope that it eventually turns into that. So I'm going to start with sine of 4t. And here's how I'm looking at it. That 4t is 2 times 2t. So if I'm thinking of this 2t as my u in the sine, double angle formula for sine, this is just sine of 2u. And the formula for sine of 2u is 2 sine of u, well, u is 2t, cosine of u. And again, u is 2t. So all I had to do was break that 4t apart into a double angle and recognize that in the formula u would be 2t. And then I have that same expression here, the sine of 2t. I can put 2 sine t cosine t in place of that, and I'll have to look at my formulas for cosine of 2t. Sine of 2t is 2 sine t cosine t. And then look at my formulas. For cosine 2t, that's the one I have 3 choices. I could use cosine square minus sine square, or 1 minus 2 sine square, or 2 cosine square minus 1. I think looking at where we're headed here, it's pretty obvious which one we need to use. I want that as a factor, and that is one of my formulas for cosine. So I can just put that in the place of cosine 2t. And then all I have to do is multiply the 2 2's, and I have it. All right. Any questions? Let's do one more, and then you can finish up that homework. Let's do 32. First thing I'm thinking is I don't have a formula for, or I don't have a double angle formula for cotangent. I have a double angle formula for tangent. How could I write cotangent 2u in terms of something that I do have a formula for? Thinking too hard about that one. Yeah, cotangent to u is 1 over tangent to u. That's the definition of cotangent. And then I have formulas for tangent to u. Actually, yeah, I only have one. 2 tangent u over 1 minus tangent squared u. So that's 1 over tangent to u is 2 tangent u over 1 minus tangent squared u. Then what? What does 1 over a fraction do to the fraction? Yeah, just take the reciprocal. That would be 1 minus tangent square u over 2 tangent u. But my answer has to be, or my right-hand side has to be in terms of cotangent instead of tangent. So what could I do? Sure, I can write tangent squared is 1 over cotangent squared. And in the denominator, tangent is 1 over cotangent. They're reciprocals of each other. Make sure that every line is equivalent to the line above it. 1 over cotangent square is tangent square, and 1 over cotangent is tangent. But it still doesn't look like this. Any ideas? You can either get a common denominator and add those two terms in the numerator, or the way I prefer to clean up complex fractions is multiply both the numerator and the denominator by the LCD of the baby fractions. The LCD is cotangent squared. So I would multiply both numerator and denominator by cotangent squared. And then distribute it. Cotangent squared times 1 is cotangent squared. And cotangent squared times 1 over cotangent squared is just 1. Now I have the numerator I wanted. In the denominator, 2 times 1 over cotangent times cotangent squared. One of the cotangents would cancel and just leave you 2 cotangent u, and that's the denominator I wanted.